Okay, so this was the question that came up, and we sort of started working through it, and then I paused. Okay, and I just wanted to double check something, and it was this part in part B. Okay, and it's the knowledge of being able to convert litres to centimetres cubed. Okay, I was a bit reluctant to say absolutely you need to know that. Okay, I just wanted to double check that. Now the simple answer is yes, it potentially could come up. Okay, I've not seen it in the last 3 years. Now that might be a sign it might come up again. Okay, but what I was told is there's certain conversions, so like time, so being able to know how many seconds are in a minute or how many minutes are in an hour, that's a pretty obvious one. Okay, how many days in a year, things like that. So quite obvious conversions. In respect of volumes, okay, litres to centimetres cubed is on the face of it quite a difficult one. Okay, however, it's essentially 1,000 centimetre cubed of volume is in a litre. Okay, so let's have a wee think about what that means. Okay, there's my pen. Okay, so essentially, centimetres cubed is a milliliter. Okay. Sorry guys, just getting my iPad up and running.
Sorry, Daniel. Why did you say millimeters then?
Millimeters?
Uh-huh.
Oh, milliliters.
Milliliters, right.
Yeah.
Okay.
Which is another confusing term. So let's have a wee look. Okay, so volumes, we're talking centimetres cubed. Okay, so what does that look like as a volume? Okay, simply just think of a cube. Okay, so a shape like that, a 2D shape, that would be meters squared or centimetres squared or millimetres squared. If we've got a 3D shape, that's your centimetres cubed. Okay, so every single side of that is going to be 1 centimetre. Okay. In a litre, there's going to be thousands of those wee cubes. So if you imagine a litre bottle of Coke, okay, probably not the easiest shape to fill with cubes, granted, okay, but if you imagine that sort of volume, okay, so that's the volume we're talking about. If you think about what a centimetre is, you think a cube made out of that, you're going to fill that volume with 1,000 of them. Okay, so if you can picture that in your head, and it's quite difficult to picture, okay, but a centimetre is quite small. So if you've got a wee cube of a centimetre, we can fit 1,000 of them tightly packed into that bottle of Coke. Okay, so 1 centimetre cubed. Okay. So 1,000 centimetres cubed equals 1 litre. Okay, and that is a conversion that we do need to know. Okay, so that's just clarifying that. So let's have a wee look at that question then. Okay, we look at that question, we found out that area, which I don't have in front of me. Okay, but we found out that area. We're looking for that
1,200, isn't it?
1,200. 1,200.
I think it's 1,200, yeah.
Okay. So we've got that area of that trapezium. Okay, 1,200. Okay, so we've got the area of that shape there, which is 1,200. centimeters squared, okay, because it's a 2D shape. Okay, remember if it's a flat shape, it's a 2D shape, it's a squared. Okay. Okay, that's 1200. Okay, and we're looking for that volume. Okay. And the tricky part of it is it's asking for L. Okay. So a volume is just the cross section, so that face there, multiplied by L. Okay, and that will give you your volume. Okay, so we can write volume of that shape is equal to 1200 multiplied by L, the length. Okay, now we've got the information that that's 156 litres. Okay, we couldn't convert litres to, sorry, we couldn't use 156 litres in this calculation, we'd have to convert it, so it was at centimetres cubed. Okay, so if we put that in, it'd be 156 times 1000. Okay, so 156,000. Okay, and it seemed quite a big number. It is quite a big number. Okay, but essentially that gets substituted in place of that V. Okay, so that would be our equation. Okay, and then it's a case of rearranging that to find L. Okay, now I'm going to cover the rearranging of equations, so we do that as part of this course. And to allow us to do these type of questions and the art questions, which very often ask for different parts to be found out. Okay, okay. Very often they ask for maybe finding out the angle or a certain length or radius here and there. Okay, very common to see that. So we need to be able to sort of, it's called transpose the equation about. Okay, so tonight I'll sort of introduce that in terms of doing it with multiplications and what that means. Okay, so we move multiplications across to the other side. Okay, so I'll show you this now, but bear in mind we'll do it later on as well when we cover the circle stuff. Okay, so that length, okay, we're looking to isolate that L. Okay, so we're looking to move this 1200 away, so we're just left with that L on, let's just say, the right hand side. Okay, so we need to move this 1200 over here. Okay, and to move something across an equal sign, okay, we change the side, we change the sign. Okay, so if it's a multiple on one side, we change it into a divide. If it's a plus on one side, we change it into a negative. Okay, so every time you cross this equal sign, you're changing the sign of it. Okay, and again, we'll cover this later on and we'll go through some pretty simple ones and we'll build up into what we need to know. Okay, so every time we cross that equal sign, every time we cross side, we're changing the sign. So to change a multiple, okay, to the other side, so taking that 1200 to the other side, it becomes a divide. Okay, so the equation becomes 156 over 1200. And I have a calculator.
$130.
Yeah, 130. Okay, so 130 centimetres. Okay, so remember the units as we go through that. So L would equal 130. Okay, so I'm going to flip that across. Just put L equals 130 centimetres. Okay.
Centimeters or centiliters?
Centimetres. So it's a length.
Right, okay.
So we changed the litres into centimetres cubed. So that's what we were doing there.
Okay.
So yeah, I agree. It's quite a confusing one. Okay, and it's It's quite rare they ask you that conversion, which is why it caught me out a little bit when I seen it. Okay, it's quite rare that they ask you that conversion. If you think of a litre and then you think about the size of a centimetre cubed, it makes sense there's 1,000 in there. Okay, so have that picture in your sort of head. Okay, so it's whatever it is times 1,000. Okay. Okay. So when you go through past papers, and we've covered most of the volume stuff now, there's a wee bit of shape stuff that was still to cover, which we'll do. But if you see any others like that, flag it up and we can go through it as a class. Okay. Any weird conversions that you see, any weird volumes that you pick out, okay, flag it up, let us know, and we can go through that as a class just so we're aware of it.
Okay.
Okay. So wee tricky one, but essentially quite nice. All right. Good spot. Okay, so that's just a wee leftover part of Tuesday. Let's get going with tonight. Okay, so we'll come back to changing the formulas about hopefully tonight. Okay, so it's actually been a while since we together and we can do stuff. Okay, so it was 16th of November, believe it or not, was the last proper class that we had. Okay, so we were looking at surds on that day, so we actually had left it with surds. We looked at fractions and surds on that day, and then we were sort of looking at simplifying some quite heavy sort of fractional stuff. So I want to start there. So where we left it, we were looking at or combining a couple of rules. Okay, so if you remember when we wrote out the rules for indices and surds, okay, let's just write that all out. AM times AN. Okay, you'll have this written down, guys, so you don't need to write it out. I'm just going through a wee reminder, just so we've got it in front of us and refresh ourselves. Okay, that should be an A. Easy. So these are just the rules of indices. So we spoke about that one for the first time on the 16th. Okay, I think it was the first time we introduced that one. I think it was the first time, I didn't watch the whole video, I just watched the end just to make sure I knew where we were. Okay, I think it was the first time we looked at that one as well. Okay, and it was certainly the first time where we put something in that format. Okay, where remember the bottom number is the root. Okay, so the bottom of the tree, the roots are there. Okay, and the top number is the power. Okay, so we sort of left it with a couple of worked examples with a couple of examples for you to have a go at. So I'll quickly run through some of the easier examples just so it's back in our head. I'll go through the examples that I left you with, okay? We'll just go through the answers. And then I'll finish that part off. Now, interestingly, I actually asked you to do them as part of those past papers, and no one asked a question about it. So I'm going to take from that, they were nice and easy. Okay, but we'll go through them, just make sure we're all in the same boat and we know what we're doing. Okay, so last three. Okay, if you need a wee reminder, I'll go back to the 16th. The video's in the YouTube channel. So, example, you have this already, so again, don't need to write it down. Okay, oops. Okay, what's that asking you to do? Okay, the cubed root. Okay, essentially what that's asking you is looking for three numbers that multiply together. Oh, that was not a question mark. Not a pen. To make the number 8. Okay, so that's what a root means. Okay, so if there's a 4 in front of the root sign, it just means what 4 numbers multiply together to make that number. If there's a 5, don't be put off by that, it just means what 5 numbers. Okay, so you can literally, on the side of your paper, write it out like that. Okay, just so it's in your head, and just work through it. Okay, so you only need to go through a couple of times. Okay, it's not 1 times 1 times 1. Okay, that just equals 1. 2 times 2 is 4 times 2 is 8. Okay, so that's what it is. Oops. Okay, that's your answer. Okay, so just getting back on track, just refreshing ourselves. Okay, let's do a wee bit more complex. Let's throw. Okay, this one at us. Okay. In the exam, for some reason, this is a really unpopular type of question. People see that and just can't compute it in that sort of pressure. When you slowly and you just break it down, it's actually quite a nice one to do. Okay, so writing that out in the format. Okay, so we know that a over n, the bottom one becomes the root, and the power stays where it is. Okay, so write that out. The bottom one, the 3 becomes the root, the power stays where it is. Okay, and it's going to ask you to evaluate that. Okay, it's going to ask you to break that down and put it in its simplest form or something along those lines. Okay, so again, first thing you're going to do is we're just going to ignore that root and we're going to work solely on the, ignore that power and we're going to work solely on the root. Okay, so first step, we just think about what 3 numbers multiply together to make 125. Just take it to one side. Question mark, question mark, question mark, equals 125. Okay, so let's just get rid of that root sign. Okay, so let's go through some numbers. 2, we know that's not going to be the case. 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is more than 16. Let's do 5. So if we do 5 times 5 times 5, okay, what does that equal? 5 times 5 is 25, times 5 again is going to be 25, 50, 75, 100, 125. Okay, so we're there, 125. Okay, so that means we've simplified that down into 5 to the power of 4. Okay, so from on the face of it, what looked quite a complex sum, okay, it's actually not too bad when you just break it down. Okay, what is 5 to the power of 4? Okay, what we're doing is, okay, just ignore that. 5 times 5 times 5 times 5. Okay, what does that equal? That is quite a tough one. Okay, we know 5 times 5 is 25, times 5 is 125. We already did that. Okay, now we need to multiply it by the other 5 as well. Okay, could this come up in a non-calculator? Absolutely. Okay, so just work through it. So it's 125 times 5. Okay, so just go through it, write it out. 125, what would the next one be? It would be 250, 375, okay, 4, 5, 500, and then 625. Okay, let's just add it up. So 1, 2, 3, 4, 5. Okay, so the answer is 625. Okay. So there's lots of wee things. If you're unsure, just write it out. Write your thinking out. Okay, and then it might just become apparent, it becomes clearer, finally clicks into place and boom. Okay, so a bit tricky one, just take your time on it. Okay. Right, let's have a wee look at the ones that I left you with.
So can I just ask a wee question about that one?
Yeah, of course.
Where does the wee 3 go? Like, do you know how it says like up in the left hand side?
This one.
Yeah.
So that is called a root. Okay, so
Yeah.
that's effectively that's a cubed root. So because that 3 is there, we're looking for 3 numbers that multiply together to make this in here.
Right, okay, yeah. Okay. Yep.
So if there was the next example I was going to give you was a 3 as well, so I'll go back. Okay, if there was a 4, give me a 4, give me a 4. If there was so example, let's say 81 3 to the 4. Okay, if that was the case, okay, now the wee number in front of the root would be that 4. Okay, and then you'd have 81 cubed. Okay, so whatever's on the bottom of that fraction, okay, goes in front of the root. And what that's telling you is how many numbers need to multiply together to get this. Okay, so for this one, we need 4 numbers that multiply together to make 81. Okay, they all need to be the same number. Okay, so times what, times what, times what equals 81. Okay, and then it's just a case of just taking your time. Okay, so it's not going to be 2 because it's not an even, but let's just work through it. 2 times 2 times 2 times 2 is going to be 4, 8, 16. Okay, so it's not going to be that. Okay, it's going to be 3 times 3 times 3 times 3. Okay, 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so the answer is 3. So we'll put in 3 cubed. Okay, because essentially you've just done that root 4. Okay, to that 81, and you've left that 3. Okay, so it's all about the order we do things, and it's always going to be easier if we do that root part first. Okay, so if you've got that in that format, it's always going to be easier if we do that root part first.
So what's that answer then? 3 to the what?
3 to the power of 3, which would be 3 times 3, so it would be 27.
No,
Thanks for explaining that there.
Missed that?
I'm just saying thanks for explaining that.
Oh, no problem.
Sorry, I don't know. I don't know. You got 27.
Okay, so might be just drawing it wrong. Oof. Okay, so that number here, the power there, remember that's just coming from the top of that fraction. Okay, so it's 81 to the power of 3 over 4. The 4 becomes the root, and the 3 stays as the power.
Right, yeah, I get
Okay,
you.
so the 3 stays where it is. Okay, the first part, we just concentrate on the root. Okay, so it's what multiplies together to 4 times to make 81.
Yeah.
Okay, the second part will deal with the power. Okay,
Okay,
so
thanks.
essentially that just becomes 3 times 3 times 3,
Okay,
and that becomes 27.
thanks very much.
Perfect. Super. Okay, so I left you on the 16th, which is a long time ago, with the questions to evaluate. Okay, 27 and 2 over 3. Okay, and the second question I left you with was 16 minus 3 over 2. Okay. Oh, minus 3 over 2. Yeah, minus 3 over 2. That's a weird one. Okay, so I left you with that. I've just thought we've not actually done a negative tonight, so let me just go through that, then I'll leave you to do these, make sure you've got them. I'll go over the answers and then I'll move on. Okay, so let me just go through a negative, what that means. Okay, so if we've got 64 to the negative 2 over 3. Okay, what does that negative tell us? Okay, so if we've got a negative power, okay, all that means is it's 1 over that. Okay, so that negative power just means the power needs to go in the bottom line. Okay, and that'll become more apparent as we go through the next step of it because we need to take powers up and down. Okay, so that will become a wee bit clearer, I promise you. Okay, so if we look at that and think about what that means then, okay, because that power is negative, this goes in the bottom like that, and it means it becomes a positive. And then we just deal with it with normal, deal with it as normal. Okay, so it just, you'll be able to write that. The 3 is in the bottom of that fraction, so it goes to the root, and then it's 64 squared. Okay, so we're going to deal with the root part first. Okay, this is essentially ignoring the power. Okay, so what 3 numbers multiply together to make 64? Okay, so so 4 times 4 is 16 times 4, sorry, 64. Okay, I did that very quickly, but just work through the normal process. So 1 times 1 times 1, 2 times 2 times 2. Once you've done a couple of them, you'll be able to see patterns and it'll jump out at you. Okay, so that becomes 4, so it actually becomes 1 over 4 squared. 4 squared is nice and easy, 1 over 16. Okay, so if there's a negative in front of the power, all that means is it's just going below the line. Okay, it becomes a denominator. Okay, so don't be scared by it, don't be put off by it. Okay, but just get it in the right format. Okay, so that should allow you to do those two. Okay, so take a wee 10 minutes. I've talked quite quickly. Okay, so take 10 minutes. We'll come back together at 10 to 7. Can't tell the time. Okay, so come back together at 10 to 7. So if you take a wee copy of that, I'm going to stop sharing my screen. Okay, if you don't mind. Sorry, hopefully that's sharing now. I forgot to click the button. Okay, so started off with that. First one was 27 2 over 3. Okay, so if we write it in the form, okay, with the root on the outside. Okay, first thing we want to focus on is that what 3 numbers multiply together to make the number 27. Okay. Okay, so 3 times 3 times 3 equals 27. Okay, so we're left with 3 squared, which is nice and easy, 9. Okay, don't get it, holler. I think I've said that in about 16 years. Okay, 16 power of negative 3 over 2. Okay, That's a negative power, so we just put that over 1. Okay. Move that root to the front. Okay. You don't need to write the 2, okay, because that's just a standard root, essentially. Okay. So what multiplies together twice? It's equals 16. Okay, nice easy one. 4 times 4. Okay, so it's 4 to the power of 3. 4 to the power of 3. It's 4 times 4 times 4, so it's 16 times 4. Okay, we did that already. It's 64. Okay, oh, sorry. 1 over. 1 over. Okay, so 1 over 64. Anyone not agree? Super. Super, super, super. Lovely. Okay, let's throw a wee bit of added complication in. Okay. And then we're going to combine our rules of Indus that we wrote out and our rules of Surds. Okay, and then combine it into nice fractions and make life complicated for ourselves just because we can. Okay, so let's have a wee think. If we've got something written like that, so if we were given that in an exam, we wouldn't be given that, but if we were given something like that, what does that mean? Okay, if we bring that square root to the top, okay, and then bring the x up, we can also write it like that. Okay, so you can do it both ways. Okay, now that's an important one just because we're going to now add other numbers in there, okay, in the top line, okay, and then bring sort of some of our roots up. Okay, so that's the simplest form of it. Okay, so if we do, no, that's 5. Okay, if we do x to the power of 4 over root of x. Okay, and we have to evaluate that. Okay, what it's asking us to do is put that root up to the top line and then put it in a singular, just a singular character. Okay, so just a single x. Okay, so simplifying that down. So we could also write that as x to the 4 over x to the half. Okay, so our root's just power and a half. Okay, we know if something's on the denominator, that power, if we bring that up to the can't talk. If we bring that up to the top line, it becomes negative. Okay, so that sum becomes x. Okay, 4 minus half. Okay, so we're combining a couple of rules there. Okay, so that's going to be equal to 3.5. Okay, so we're taking a half away from 4. Okay, so 3.5. Okay, or if we're tidying that up, it could be 7 over 2. Okay, because there's 3 wholes. Okay, so that fraction would just be 7 over 2. Okay. This step's quite an interesting one. Okay, that power step. Might throw you a wee bit, first couple. Okay. Example 2.
Sorry, can I just ask a wee question about that first one?
Yep.
I think I missed where you got the half from.
So that's just what a standard square root is.
Right, okay.
Okay, so we don't usually write the 2 in front of a square root, but if you got the question, what is the square root of 4? Essentially what that's asking is what 2 numbers multiply together to make 4. Okay, so the answer is always
Yeah.
2. Okay,
Okay, yeah.
so we were writing that out in the format that we've been writing out recently, okay, or tonight. Okay, you could write that like that. Okay, but it's just one of these quirks in maths. Okay, like in algebra where we don't put a 1 in front of the x even though it should be there. Okay, or we don't write 1 when it's x to the power of 1. Okay, it's just one of those little quirks. We don't write the 2 in front of just a standard root. Okay, so that's actually just 4 to the power of half. Okay, so if you had x like that, it'd just be x to the power of half. Okay, we just don't write the 2 in front of it. Okay, it's just there to confuse you, really. Okay, so that x to the half, okay, that can convert to that. Okay, essentially we're saying it's x to the power of 1 to the root of 2. Okay. Just to throw you. Okay, so it's just one of these wee quirks. It's just a standard square root. Okay. Again, I like to use really simple examples to sort of have in my armoury just in case I forget something like that. Alright, so if you forget, oh God, what's just a standard square root, how many blah blah blah, just do the square root of 4 equals 2 and just think about what that means. Okay, what 2 numbers multiply together to make the number 4? Okay. I wish I had another simpler example. I seem to be jumping quite a bit with it. Okay, a to the power of 4 multiplied by 3a divided by root of a. Okay, so when you've got something like this, what you need to do is deal with the top line first. Okay, deal with the powers up in the top line first using your rules of inness, and then we'll deal with the division afterwards. Okay, and this again comes back to just the way that we order, the order of which we do things. Okay, so essentially you can do a divide and multiply either order. Okay, it's just really what's most simple for the sum that you're doing at the time. Okay, so if we do the multiple first, we deal and tidy that top line up. It makes life easier when we want to tidy up the bottom line. Okay, so let's have a wee look at that. That top line, okay, just becomes 3a to the 5. Okay, then the denominator stays the same. Okay, so that's just the rules of inness that we're doing there. Okay, so that's just 3a to the power of 1. Okay, and that's just 1a to the power of 4. Okay, remember it's just those wee quirks that makes life a little bit tougher for us, but that's essentially all that's saying. Okay, so when you're multiplying indices, you're essentially just doing the 4 plus 1, and it becomes 5. Okay, the 3 multiplies by the 1 in front of the a, and just becomes 3. Okay, so we've tidied that up, and it's a little bit more manageable now. Okay, so we've got 3a to the power of 5. And if we say that to the half, and it just makes life a little bit easier. Okay. 3a 5 minus half. Okay. Now you can. Oh, sorry, someone's waiting in the room. Sorry, Hannah, that was, I don't know how long you've been there. Okay. So 5 minus a half, you could have 4.5. Okay, or you could put it into a wee bit of a better form. Okay. Oops. So you could take that over. Okay, and think about what that is. Okay, so 5 minus a half. Okay, 5 is just 5 divided by 1. Okay, so we're just doing our smile kiss, essentially. Okay, and that just becomes, we went through that process, 9/2. Okay, now you could write 4.5. Okay, but that's probably the better format to be in. Okay. Okay. Does everyone get that step? Not jumped ahead and confused matters, confused things. Okay, what I've done there. Okay, so when we're adding indices, if we're doing a number by another number, okay, and you're adding fractions, you just do the smile kiss and it's easier to do. Okay, so we've got 3 to the power of 9/2. Essentially, well, not essentially, we can write that as that. So that would be our final result. Okay. Okay, let's have a wee 15-minute break. I actually meant to do a wee break after the examples. I got carried away. Okay, so let's have a wee. Right, let's make it 20. Let's come back out together at 25 past. Okay, so let's take a wee 20-minute break. Just take a wee breather. Have a wee look through that again and just compare that against your rules of Indus. Okay, and just see what rules we're using there. Okay. And then we'll come back. Okay, so we'll come back at 25 past 7. Look through that. If you've got any questions, if you want me to explain it again, I'll go through it again and maybe try it a different way. Okay, so just try and digest that, and I'll see you at 25 past.
No, not gonna answer them.
Does it make a wee bit of sense? I'll go over a couple more examples, but don't want to go too fast if you're not getting it. It is a wee bit tricky where it's all going, okay, but again, once you've done a couple, once you see a couple of past paper questions, it'll become apparent. Okay, so let's continue. I can get my iPad open. Sorry guys, 2 seconds. Have a look. Let's have a look. Let's have a look. So we just did a to the power of 4 times 3a. That's cool. Share my screen. Next one. Okay, let's have a couple more. Okay, so similar sort of question then. Okay, just with a few more. That should be a 7. So 6a times 3a to the power of 7 divided by 9 root a. Okay, so a lot going on. Okay, but let's just break that down. Go through chunk by chunk. Okay. So first thing I want to do is just tidy up that top bit. Okay, as I was saying, let's tidy up. It's all about that process you go through. So I'm going to do the multiplication first. 6a, which is to the power of 1, multiplied by 3a to the power of 7. Okay, so that's 6 and the 3 multiplied together to make 18. The a to the power of 1 and a to the power of 7, those powers will then add together. Okay, so that's just using our rules of Indus for that. Okay, so that becomes, I was looking at the wrong answer there. A to the power of 8 over 9 root e. Okay. Something that we can do here is just tidy this up a wee bit. Okay. So remember, when you've got a multiple at the top, okay, so that's 18 times root a effectively, and then 18 times a to the power of 8, and then 9 times root a. Okay, we can cancel out some of the stuff there and just tidy that equation up, make it look a wee bit easier for us. Okay, and so that 18 and that 9, okay, they're both in the 9 times table. Okay, 18 is 9 times 2, and 9 is obviously 9 times 1, so we can cancel some of that out, and we can simplify that down to 2a to the power of 8 over root a. Okay, that means we can do that next step, the 2a to 8 over a to the half. Okay, and because that's the denominator, when we bring that up, the power becomes a negative. Okay, so when we bring that up to the top line, that power becomes a negative. Okay, and we go to 8 to negative half. Okay, so essentially that's 8 minus a half. Okay, Now I'm going to do that same process I did in the last question. So I'm going to take that over to one side and I'm going to do this kiss smile thing. Okay, I'm not just going to leave it as 8.5. Okay, so 8 is essentially 8 over 1 minus a half. Okay, so if we do our kiss smile, okay, so that's 16 minus 1 is 15 over 2. Okay, so that leaves us with 2a 15 over 2. Okay. Okay, that just tidies that up. Okay, and we leave it in that format. Okay. Let's have a wee go at. I'm gonna write these numbers up. Okay, that's good. 4a, 4 root a multiplied by 3a to the power of 6 divided by 2a to the power of 4. Okay, so a hell of a lot going on. Okay, hell of a lot going on there. So let's start breaking that down. Okay, so we've got top line. So let's tidy up that top line first. So let's put that first term like that. Okay, over to 8. Okay, so we've done nothing to the bottom term yet. Okay, we're just starting to tidy up the top term. Okay, and when we're doing our indices, it's easier to have it as a half there. Okay, so the power is just taking into taking into account the root. Okay, so when we're doing our power of indices, that's going to become 12 a to the half plus 6. Okay, so that half plus 6 take over to one side. Okay, so we've got half plus, remember, whole number is essentially just a number over 1. Okay. Do our kiss smile process. Okay, so that's the last video, so if you're unsure what I mean by kiss smile, just go back to the last video. Okay, multiply the two terms, that's 6 plus 12, so that's 13 over 2. Okay, well, okay, so 12, that's 13 over, sorry, 12a, 13 over 2, 2a to the 4. Okay, have we lost anyone? Seem to be okay. Okay. What can we do at this stage? Okay, we can simplify that down. Okay, and cancel out a couple of things. Okay, so we can cancel out that 2 in the bottom and just leave us with a to a power. Okay, so we can cancel that down. That'll become 6a to the 13 over 2, a to the 4. Okay. Going to bring that denominator up. That 4 becomes a negative 4. Okay. Again, I'm going to take this to one side and we'll just sort that. Okay, so 13 over 2 minus 4 over 1. Okay, we'll just do our kiss smile. Okay, so 13 minus 8 over 2. So that's 5 over 2. Okay, is that correct? Yeah. Okay, so we bring that back in, and then we just tidy this. Oh, sorry, got to put the A. Okay, and just tidy that up. Okay. These ones aren't the easiest and sometimes take a wee bit of practice. Okay. What I would say is in an exam, that would sometimes give you your marks, okay? That part there. However, they sometimes do ask in the question in surd form, okay? So evaluate and leave in surd form or something along that line, okay? That would be in surd form. Okay, you're left with that surd. Okay, so remember those roots, we're just calling a surd. Okay. Okay. Got down here page 15. Not that. That's page 15, question 14. Page 15. So this is just the booklet. So pack 1. Page 14, oh sorry, page 15. There we go. All right, page 15 in that booklet. And there's question 14, which is all about roots and indices. Okay, and then there's some like past paper questions there as well. Okay. Which essentially do what we did there. Okay. So what have we got to do? Right, we won't stop at this point. We'll go on to the next wee bit. Okay, because it's quite important. Just thinking of what order to do this in. Okay, so we won't stop at that point, but that's where your questions are. So if you have a wee go at that, remember the answers at the back. Okay, there's also some of those questions in those past paper sort of unit practice questions that I sent you in that email. Okay, so there's a bunch in them. I've not sent you the answers for that yet. I've still to write them out fully, okay, in a neat manner. That's all I'm waiting on, just putting them in a neat fashion. Then I'll email you them across so you have that together. Okay. So the next part, we're going to move completely away from surds. Okay, I didn't expect to spend so long on that. Okay, we're going to do something called completing the square. Okay, and this is a funny wee process. But remember, at this stage, we're still in our first, the first sort of part. Okay, the first unit, that's the word I was looking for. Still in our first unit, so we're learning the foundations. So this and circles and a wee bit of straight line stuff, okay, is the last part of that. So we're really just learning the foundation knowledge behind it. What this process is of completing a square is something that we do to trinomials. And to understand exactly what we're doing, you need to, once we start looking at trinomials more fully, it becomes apparent what this is trying to tell us. So essentially, we're taking a trinomial. And remember, trinomials are in the form ax squared plus bx plus C. Okay. So what these algebraic expressions are, okay, and what they're telling us is we can substitute in different numbers to that, and then that would be reflected and it would be able to graph that. Okay, so it's essentially we're trying to read graphs. Okay, graphs are pretty important. So straight line graphs tell us like how things change over time. Quadratics are important they help us make decisions. Okay, so big algorithms will use quadratics to help us make decisions. Okay, so essentially, if we were to draw out, or when we do draw out these types of graphs using trinomials, okay, it's going to be our x-axis, that's going to be our y-axis. They're going to give us shapes like this. Okay, so they're going to give us curves. So if we were to substitute in numbers along the x-axis, we'd be able to effectively find bits of that curve. Okay. Now what all the wee things that we're doing, so like completing the square and finding the factors and things like that, what that's telling us when we're working with trinomials is it's telling us different information about the shape that we are going to draw. Okay, so in Unit 3, when we start drawing these trinomials out, we start understanding it, okay, and we start getting to grips with it. Factorising and completing the square tells us different information. So it tells us things like where the maximum is, okay, so where the top of that peak's going to be. Okay, factorisation tells us where it crosses the x-axis. Okay, completing the square also tells us the shape, the way up the curve is going to be. Okay, so you can get it with a maximum on the top, or you could get the curve as a minimum like that type of shape. So completing the square tells us where the minimum's going to be, and it tells us the shape of it. Okay, so all these wee things that we're learning will become useful. Okay, so this process I'm going through, you might look at it and go, why do we need to know that? Okay, it's quite important. Using things like this, as long as it looks, is the way that decisions are made. Okay, so investment bankers or Amazon's algorithms behind the scenes all make decisions about things. Okay, and it's using trinomials, it's using different variables to pick out things. Okay, so they are pretty useful. Okay, majority of people will never use this again, but a lot of people do. Okay, and it's exciting. Okay, so we're going to do completing the square. So just bear that in mind, it is useful later on. Okay, so we're just learning this technique. The completing the squares, another one of these things, but I'm going to write it out and the process will look a wee bit odd, will look a wee bit weird. Okay, and it's one of these things that when I go through BBC Bite Size and look at dynamic notes and compare and contrast the way that each of them explain it, they are explaining it the same way, but they'll use slightly different wording and methodologies. So I'll make sure that we go through each of them as well. Just so if you're sitting in BBC Bite Size at the weekend and you look at it and go, that is nothing like what Daniel was saying. All right. So I'll make sure we do that as well. We'll just go into BBC Bite Size and we'll look exactly what it's saying and we'll compare and contrast. Okay. So simple, we've got trinomial bracket in the format ax squared plus bx plus c. Okay, so remember a, b, and c, they're just holders for different numbers. Okay, different numbers in front of that x squared. Okay, or different numbers in front of any of the terms. Okay, so don't be put off by those letters. What we're changing the format to, okay, so we are changing the format x plus b over 2 squared, okay, minus b over 2 squared plus c. Now that looks really, really odd. So let's do some example. Let's put some numbers into this so it starts building up and makes sense. Okay. Again, there's rhyming reasons behind the scenes of why we do this. Okay, so let's do example 1. Okay, so if we have x squared plus 6x plus 2, okay, we're wanting to put it in that format and then tidy it up. Okay, so we put a bracket, x plus b. Okay, so that's our b term there. So it's b over 2, so it's 6 divided by 2. Close bracket, and then that's going to be squared. Okay, then we're going to be minus. That's very important. That's always minus. Okay, and you'll see why that might become confusing later on. Okay, but that's always minus. Okay, 6 divided by 2 squared plus c. Okay, so c is that term there. Okay, so plus 2. Okay, and then it's just a case of tidying that up. Okay, then it's just a case of working through that, tidying those terms up. So 6 over 2 is 3 squared, 9 plus 2. Okay, that's it. That's completing the square. Okay, it's relatively straightforward, but again, it's just putting in a different format to tell us different information about that trinomial shape that we'll draw later on. Okay, so again, we'll come back to this. Okay. Okay, so let's do another example. Okay. If I skip a page and you want me to go back, just give me a wee shout. All right. Example 2, same sort of thing. Okay, x squared plus 8x plus 3. Okay, we're wanting it in the format x plus b over 2 squared minus b over 2 squared plus c. Okay, so x, b over 2, okay, it's just 8 over 2 squared minus 8 over 2 squared plus c, which is 3. Okay.
See the formula we need to put it in, is that on the exam sheet or do we need to remember that?
Great. So I'll go through that. So I will ask you, so the question's really interesting. I will ask you to put it in a form and you need to recognise that form as completing the square. So really good point. And I don't know why I'm pointing. Okay, and I'll go through that. So
Okay,
well picked up. So 8 over 2 is 4, so 4 squared is 16 plus 3. Okay, x plus 4 squared minus 13. Okay, so that will tie in when we look at BBC Bite Size and Dynamic Notes. Okay, because I really want to look at that. It's all the same method, but it's all slightly different wording, slightly different letters, and especially the way Dynamic Notes do it, people get really confused by it. Okay, don't want to scare you, but we'll do. Okay, but it's all the same. Okay. Okay, so let's throw a wee negative in there. Okay, and see what it does. Okay, so that's the final answer, completing the square, no problem. Let's do x squared minus 8x plus 5. Okay, so the difference here is just this wee minus. Okay, so let's see how we deal with that. Okay, x, stick the first term in the bracket. Okay, so that's going to be the same. that's going to be negative, because that's negative. Okay, so it's going to be b over 2, so it's going to be negative 8 over 2. Squaring that. Okay, this is the wee confusing bit here. That sign stays negative. In the bracket, you're going to put negative 8 over 2 squared. Okay, and then your plus your c term, which is 5. Okay, and I say people sometimes get confused at this stage. Okay, because if you square a negative number, it becomes positive. Okay, so if you remember what a square is, okay, a square is just a number times by itself. Okay, so let's just simplify this, tidy this up a wee bit. X minus 4 squared minus 4 squared plus 5. Okay, so this bit, okay, sometimes is where people get a wee bit lost. And they don't recognise that if we square minus 4, it becomes a positive. Okay, and then that gets taken into account. So essentially what I'm saying, that would be negative 16. Okay. Okay, so remember we're dealing with the bracket first. So if we were going to do that, if we were going to essentially break out that bracket, it would just be negative 4 squared, which would be 16. So in that place, in here, we would put the number 16. We've not done anything to this figure, this character. Okay, that negative, so it stays negative. Okay, it sometimes throws people a wee bit, that being a negative squared. Okay, and why that happens. Okay, but essentially just deal with that on its own, work out what the number is, and then just substitute it in. Okay. Let's do another one with a wee negative in it. Okay, so we're happy with it. X squared minus 10x plus 12. Same process. X minus 10 over 2 squared minus 10 squared plus 12. Okay. Oh, that's over 2, sorry. See how easy it is to forget. X minus 5 squared minus 5 squared plus 12. Okay, so if we were to do minus 5 squared, that would equal 25. Okay, so remember when you times a negative by itself, so negative 5 times negative 5, you'll get a positive. Okay, so that's what we're doing there, so just be careful. Okay, so that becomes positive 25, and then that sign goes in front of it. Okay, so x minus 5 squared minus 25 plus 12. Just tidy up the last two terms. Okay, you'll get your answer. Okay, in fact I'll do the next one because it's two negatives. Okay, perfect. Okay, so I'll give you one more wee example. In fact, I'll give you two more examples. Okay, just so you've got them. X squared minus 6x minus 4. Okay, minus 6 over 2. Okay, minus 6 over 2 squared. Okay. C in this case is minus 4. Okay, so that becomes a minus 4. Okay, so that, just be careful with that sign, that it matches that. Oops. Okay, so that sign matches that sign. Okay, so just be careful with that. So the last 3 examples that have ended up with minus 13. Weird, eh? Okay. I'll give you one more, and then I'll give you a couple of practice ones, and then I'll review bite size and dynamics, and then we'll call it a night. Alright, so what did I say? Give you one more, didn't I? Okay, so we had x squared plus 4x. Okay. That's still a trinomial, okay, that we can complete the square with. Okay, that's still in the format of ax squared plus bx plus c. There just doesn't happen to be a c. C is 0 in this case. Okay, so essentially you can still do the same process, we just don't have that plus c. Okay, but don't let that throw you. Okay, so let's put it into the format. X plus 4 over 2 squared minus 4 over 2 squared. And then there's just nothing after that. Okay, there's just no c value. Okay, I'll give you 2 to try. Take 10 minutes to do that. Then I'll do the review of such and such. Okay, so view, give these a go. X squared minus confuse myself here. Okay, just give them a go. Okay, and just put that in the format. Okay, so let's take 10 minutes. 10 minutes doing that. Okay, so come back. I'll come back on at 10 past 8. Okay, so same process. That b term's getting halved. Okay, so x, that's going to be negative in this case. Okay, so Looking at the answer for the second one. Okay, negative 12 over 2, that's going to be squared. Okay, negative 12 over 2 squared, negative 10. Okay.
I don't know what that means.
Anyone not see that? Not get that? Okay, everyone okay with that? Nice one. Okay, so that's completing the square. So not overly complex. Okay, it means a wee thing. Always comes up. Absolute guaranteed to come up. Okay, should be a nice easy way to make a couple of marks in your exam. Okay, always comes up. But let's look at BBC Bite Size. Let's look at dynamic notes and just look at the way that they've written it out so it makes sense to us. Okay, just in case you're using these resources. Okay, so I can put that away. In fact, you know what? I'll keep that open. I'll keep it open so we can look back. Okay, so oh, that was me just converting that just to double check. Okay, so BBC Bite Size. BBC Bite Size Math, Nat 5. Okay, let's have a wee look at what we've done tonight. Okay, so tonight we did a wee bit of surds and then working with fractions. Okay, so that's what we did the first hour. Okay, and then we moved on to this completing the square in a quadratic expression. Okay, so completing the square in a quadratic expression. Let's have a wee look. Okay, so they don't give you much to go on. Okay, they just give you 1 and 2. Okay, completing the square, blah blah blah, convenient. Okay, so that first part doesn't tell you much. Okay, it won't make much sense. You can see it's starting to put it in a format that we just sort of looked at and we're familiar with. Okay, so let's look at their worked example. Okay, so rewrite y equals x squared minus 6x plus 11 in that form. Okay, now they've used the letters minus b, okay, and plus c. Okay. So let's just work through it. To get b, the number inside the bracket, half the coefficient, so that's what we were doing, the second term of the original equation. Okay, so half of minus 6 becomes minus 3. Okay, so that's the exact same as what we did. Okay, so to get b, the number inside the bracket, half the coefficient, the number in front, the second term in the original equation. I think that as a sentence is just pretty damn poor. All right, that's what we did. So we halved the coefficient of the number in front of b. That's all we did there. Okay, you can see why I sometimes don't like. Right, so that's saying the exact same thing, and then they've got that minus 9. Okay, did they even say where they're getting that minus 9 from? B, half the coefficient of the second number of the original equation.
X is minus.
Alright, sorry, where did we get the minus 9 from? Okay, so they don't say where they got the minus 9 from, so that's a good start. Look again at above, expanding. Yeah, I don't know why they're going into that detail. You don't need to know that. Alright, it doesn't make your life easier. Okay, that answer there is the same answer as what we would get. Alright, so this adds no value. Simple as that. Alright, so blah 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 blah. Yeah. I think as an explanation for completing the square, BBC bite size, that's probably the worst example I've ever seen. It just doesn't make sense.
So Daniel, in the exam question then, will that say complete the square or?
Yeah, so let me do dynamic notes and then we'll have a look at the exam questions. So yes, it will say put in the form of. So that first line in BBC bite size is similar to what you'd see as an exam question.
Oh, right.
You have to recognise that form that they're asking you to put in is completing the square. I don't really know what I'm doing there, to be perfectly brutally honest. All right.
Right.
If you do that practice question with the method we did, you'll get the same answer. All right. You'll get the same answer. Okay. If anyone can make sense of that and teach me, then let me know. Okay, so let's have a wee look at dynamic notes because it's a cracker. Alright. Dynamic notes. So find this in Moodle, guys, remember? So it's the dynamic notes is the notes that I like the best. Alright, it does break it down quite well in most cases. Okay. Just in completing the squares, it throws in some added complication that does confuse people. Okay, so completing the square, let's zoom in a wee bit. Okay, so process of writing that trinomial, so we recognise that form, okay, in the form of y equals ax plus p bracket squared plus q. Okay, so that form, okay, similar to what you'd see in an exam.
Right.
Okay, so what they're saying is this letter P has its own equation, and that letter Q has its own equation. Okay, and then they substitute that in at a later point. Okay, so let me go through that and let me have a wee look. Okay, so that's called completing the square. The completed square is a form of equation, blah 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 blah. So that's really just that's just saying what I said at the start. So you can easily determine max, min, blah 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 from the graphs. Okay. We use the fact the number in the bracket is half the coefficient of b. All right.
So write blah 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 on the exam paper.
Blah blah blah. Okay, so this is what they do here. So they say that letter P is just B over 2.
Oh, that's what we were
Where I
doing,
just
wasn't it?
wrote in B over 2, they've put in the letter P instead. Okay, just to throw that wee bit of confusion. So essentially we're taking the B here, dividing it by 2, and then substituting it in at a later point. Okay, and then Q is just minus P squared plus C. Okay, I think this is adding confusion that doesn't need to be added, but I didn't want you to read this on your own and worry about it. Okay, let's just go through the same examples that we went through, but using this sort of format. Okay, just so you can understand and see it. Okay, so if we, in fact, I'll just use the examples they use. So if I go back to that, okay, so, sorry, I need to get a question. Close that. Okay, so the question is express x squared plus 8x. I'm just writing down the question so I've got it in front of me in the form. X plus P plus Q. Okay. I'll share my screen in 2 seconds, guys. Okay. Right, so that's me just written out that question. So express x squared plus 8x plus 3 in the form of that, okay? So we'll look at exam questions in a second, but that's pretty familiar or pretty similar to what you'll get. So you get asked to put it in this sort of format, okay? And you'll have to know that value going in there. You'll have to know the value going in there is just b over 2. Okay, so in this case it's going to be 8 over 2. Okay, and q is just that longer bit. Okay, so the b over 2 squared plus c. Okay, so it's the exact same as what we did. They just add a wee bit of added complication to try and make it look a wee bit neater. That's essentially all they're doing. They're just trying to make the process look a wee bit neater by creating something to substitute back in. Okay, so they're just substituting b over 2 back into there. Okay, so let's write that out. So if we were to find out what p is, it's just 8 over 2, so p equals 4. Okay, so we can take the fact that p equals 4 and substitute it into this, and then substitute it into that. Okay, so q is minus 4 squared plus c is plus 3. So q is minus 16 plus 3. Q does always end up at minus 13. It's a fourth. Anyway. Okay, so now we've got what P is and we've got what Q is. It's just a case of taking P and substituting it in there, and taking Q and substituting it in there. Okay, so in the form x plus P squared plus Q, where P is 4 And Q is negative 13. That's your answer. Okay, so it is the same method, but they've just added a wee bit of added complication in there for just to make it look a wee bit neater. Okay, just to make it look a wee bit more mathy. Okay. Does that still make sense when thinking about what we did? Okay, so we're just doing this substitution thing. So I don't think you've looked at substitution, but that's essentially what we're doing. Okay, so they've got another example in which they've got, yeah, they've got another example that you can look at. Only 2 examples there. All right, so not many. Okay, but that's what they're meaning. So the P equals B over 2 is just what we did, and this is just what we did as well. Okay, I just wrote it out fully because it's a wee bit simpler. I think that it's complicated for complicated's sake. Okay, so you asked what it looks like in the past papers. Great question. So let's look at PDF is closed. Okay, simplify, express, brackets, blah, 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 blah. There we go. Okay, that's what you would see in an exam. So you can see.
Oh, yeah, completing the square, yeah.
Yeah. So you'd see the trinomial, and then you're getting asked to put it in that form. So you're asked, what it's asking you is you recognise that as completing the square process. You can write that out whatever way you want. Okay. As long as you get the right answer, obviously. But that's the question they'll ask you.
Thank you.
Okay. So it's a nice one for probably we're talking 3 marks. Okay, so knowing what P is, knowing what Q is, working that out, and then writing it all together. Okay, a nice wee 3 marker. Okay, so I'll send you through the answers to that, so you'll have the answers to that shortly once I write it out neatly. Okay.
Okay.
That's 8:30, so I don't see any value in starting anything else. Okay, because we're all a bit tired by this point. So next week we'll just jump straight on to arcs and circles.
Are we going back to Tuesday?
Not Tuesday, so next Thursday. We'll go back to Thursdays.
Okay.
Okay. Remember, I'm available, so drop me an email. I'm a wee bit quieter now. Busy couple of weeks with that competition and stuff like that, so that's quite good. Just to say, completing the square, there's questions in that booklet. In this booklet, they are on page 29. Let's have a look. Page 29, question 1 and 2, I've got down here. Yeah, page 29, 1 and 2.
Okay.
Some practice ones there. Okay. So in the form, and you'll see. Okay. Perfecto. Okay, guys. Anyone got any questions before we stop then? Super. Okay. If you do, remember, send me an email. Hopefully, I'll try my best to get back to it. Okay. If not, next Thursday as normal. Okay, 6 o'clock. Okay. Okay. Appreciate that, guys, and I'll.